So today we're gonna talk about input-output. So unfortunately, my laptop was not working properly, so I switched to the desktop. So the desktop, the problem is then I cannot write on top. So I mainly will demonstrate and explain. So today we're gonna show you the input-output. So it's related to data. Okay, and so we start with two building functions, save and load. Save is saying, for example, I show you the very simple example. For example, I give I assign 1 to A, and B is, for example, 2 plus A. Okay, you have A and B. Okay, so now I accidentally typed in clear all. Okay, and the CLC means clear everything. Clear all means clear all data. So then you deleted A and B. Okay, so now I'm telling you, when you create this data, okay, if you want to make a copy, you say save. Okay, so when you say save, it's automatically created. You can see current folder. Okay, here automatically you save the A and B to this temporary folder called matlab.mat. So when you clear, so A and B you created here in workspace. Okay, you clear all. Okay, so you note that workspace you cleared all the variable. Okay, so you don't have A and B. And but it would, because you type in save, so it's temporarily saved in matlab.mat, so you can type load to get back them. So load will restore the data from the matlab.mat. So now you call A and call B, you get back. Okay, so this is the save and load. One is store the data, and the load is restore data. Okay, so this is two building function to start with. So now we start from the data type, and then we were talking about later how to print out all different data type. So we talk about matrices, vectors using a double data type. It means real numbers. Okay. Now today we're gonna study a new data type called string, or we call character. So string, it can be letter, okay, can be number mixed with letter, or can be number, or can be special characters. But when you define, should put a single quotes around it. Okay, so this is a definition. Now I'm going to demonstrate to you. So for example, I assign a string to A. Okay, if you type by mistake, you typed double quotes, so it won't work. Okay, or you didn't type single quotes, didn't type any quotes, it won't work as well. So when you assign string to a variable, must put a single quotes. Okay, so this is how to define a string in MATLAB. So double quote doesn't work. And also a string work like a vector. That means, for example, we defined ABC. Let's not assign to it to small a. Let's assign to capital A. So now, basically, this variable a basically can be worked like a vector. So that means you can grab any letter from A by point out the location of the letter you want to grab. For example, I want to grab the first letter. You just say the first, okay? Point out this. Or you say, I want the end, I want the last letter from the string. So it's C. So point out the location of the letter you want to grab. You can always grab. Okay, so this is the string. And the following few slides I would prefer to show you in such a way. For example, I assign 0 to variable a. Okay? So you say a plus 1 is obviously is 1. Okay? Now, what happens? Okay, I assign a string 0 to b. So A and B are different, although it showed in command window, it print out looks like the same, but it's different because A is a number, A is a variable, represents 0, but B is a variable, represents string. This string is 0. Okay, so it's very easy. A quick test is B plus 1, a string plus 1. It should not be 1, right? So it's some strange number. Okay, so this is you can test. This is a string. It's not a number. So why is that? It's because when computers store string, is based on ASCII code. So what is ASCII code? It's a table, actually. So this table divides to the dark column and the light column, the bright column. So the white column actually stored all possible string. And the shaded column is corresponding number that MATLAB used to represent the string. For example, I put 0 here. Okay? 0 is a string. So you look for the dark column. So actually it's 48 represents 0 according to this ASCII table. Okay? So that's why I said that 0 string plus 1. So MATLAB will automatically compute 48 plus 1. That's where you get 49. Okay? So that is just show you how MATLAB store string. Okay, now we show you another example. Okay. So I assign string ABC to text. And now I say this plus 1. So it gives you 3 numbers. So why is that? Because when I assign ABC to text, okay, so actually MATLAB store, it went to ASCII table, ABC is here. So MATLAB will store 97, 98, 99. And when you say ABC, this string plus 1, so each of the value plus 1. So you get shifted version. It's 98, 99, 100. That clear? Okay, that's where you get this. Okay, so this is the ASCII table. Okay, and this is our example. So so now we talk about a few more building function about string. So CHAR in fact is telling you CHAR with the brackets with certain input. That input normally is number. Okay, so CHAR is map this dark column to the white column. Okay, give you a number, you map to string. Okay, so ABC plus 1, we have demonstrated. Okay, this string ABC plus 1 is just 3 numbers. Okay, if you put a CHAR, okay, if you put CHAR, you look 98, 99, or 100, these 3. Okay, so CHAR will map to the white column, so you get BCD. Okay, so let's see. So it's BCD. Okay, and so we have another 2 important building functions: string to number, number to string. So this is, for example, this is when you say string to number. When you give a string, so you put string to number, you convert this string to number and assign to A. So A equals 1, 2, 3. You want to make sure it's a number, so simple test is A plus 1. It should give you a number 1, 2, 4, right? So it is, you get a number, okay, string to number. So you can also say number to string. So number to string, the input should be number, so without single quotes, okay? So you input number 1, 2, 3, and it converts to string and assign to A. Now A is a string, so you can test A plus 1. It won't give you 1, 2, 4. Okay, it gives you 3 number. So this is the number to string, string to number. Okay, 3 building function. And now another building function, input. Input, we have talked about this input in last lecture. So I'm going to demonstrate to you. For example, we say input, okay? Input a number. Okay, now it print out this bunch of text, this line of text, and wait for you input a number. When you input 3, so it automatically takes 3 assigned to A. Okay, this is when you input a number. Now we say input a name. So for example, we input Bob. Okay, it doesn't work. So by let me control it. So that's because when you didn't specify it by default, MATLAB expecting a number from you. Okay, so if you want to input a string, you're gonna specify it's a string. Add 1 argument here. So then this allow you to input a string. Okay, input a string, you have to put an extra specification. Okay, extra argument. So this is how we input a string. Okay. So we talk about input. Now we move our focus to output. So output, we mentioned display before. Display a variable, a value. Okay, display a line of text. But display is the simple printout. Okay, because you can't format. You can't format that, the printout. So today we're gonna introduce a sophisticated printout. It's called fprintf. So this function allows you to format the printout in a way that you plan to. Okay, so F stands for format printout. Okay, let's see how it works. So the syntax is like fprintf followed by the format that you want with the single quotes. Okay, first format and then followed by the variable that you plan to print out. So here is an example of tank volume that we talk about. In fact, it's last lecture. It's about this. So giving you a tank, giving you a radius, giving you a height, and calculate the volume. So last lecture, we studied this by building a MATLAB function. Okay, so now we see this example. Clear everything. So you input tank radius and assign to R. Input height, assign to H. So then you call this function tank volume to compute the volume. And then you say fprintf to print out the volume. Okay, this is the idea. Okay, so when you use fprintf, follow this syntax. So what you have here is format. So followed by the variable you're gonna print out. So when you see this format, so MATLAB will print out volume of tank is this text directly print out. And then MATLAB will see %F. So then MATLAB will understand, oh, this is to let you print out a variable. So MATLAB will go to grab this value and print out in this way, %F. So what is %F? I'm gonna show you here. So %F is a conversion specifier, okay? So it's tell you how you want this printout, okay? So there's quite a few specifiers. We talk about this first. %F, okay? %F is when you print out an infinite number, pi, or whatever number. It can be integer, can be any decimals. So you want to print out in the format %F. So this is called fixed point printout. That means after this dot, it must be followed by 6 digits. Always see, we always print out in 6 decimal places. Okay, so let me demonstrate you here. fprintf, for example, we say %F, okay? So followed by the variable you're gonna print out. Let's not input pi, let's input an integer, for example. So this %F, as I said, is fixed point printout. It always print out 6 decimal places. So some of the input like integers or 2.1, it has not up to 6 decimal places. So it will fit 0. Okay, so this is what you print out. It's always, this is 6 decimal places. Okay, and this is fprintf. And then %E is exponential printout. %S is a string. Okay, %D, if its input is integer, it's integer itself. Okay, %G is up to 5 decimal places. Okay, if your input is shorter than 5 decimal places, it print out this short input directly. Okay, so it's up to 5 digits. But if you can't remember now, it doesn't matter. I think in your lab you have a chance to practice more about that. So that is %F. Okay. Now I'm demonstrate you this. For example, you can also print out, okay, multiple variables in different format. It doesn't matter. The format, it's up to you. You decide. Okay. So, for example, I say pi 2. Okay. So I'm gonna, for example, I'm gonna print out these 2 variables. And the format is one is fixed point and one is %D. Okay. So for multiple variable printout, you're gonna specify each of the variables format printout. Okay. So this is what you get. First pi is fixed point printout. You have 6 decimal places. Second is integer. It's print out integer itself. So now, when we print out this, you notice that the line right after this printout, okay, it's quite ugly. So how do we start a new line? So that means the line is not right after the printout. It's start from the next line. So what we can do is, after this printout, this format specifier, you put a \n. Okay, that \n means start a new line, and you normally put after the specifier. And of course, you can. It's up to you. So you can even start after 3 lines. Okay, so you add a space. So \n. And there's more special characters I'm going to introduce. \t is tab space. \b is backspace. If you want print out single quote, you insert the double quote, and double percentage, you print out single percentage. Let me demonstrate you all these all these special things one by one. For example, you print out this line of text, okay? Start a new line. So this is you print out the entire sentence. Now, we talk about \t here. \t, as I said, is called a tab space, okay? You insert \t is equivalent to say, now you create a space between this and is. Okay? And is and it, you can also put a \t. So basically, the printout is going to be the same as the previous printout. Okay? So this is a tab space. It's automatically created space. Okay? So this is \t. Now I'm going to introduce another one. Is called \b. For example, I print out hello. Okay? Now, what happens if I put a \b? B means backspace. Okay? So this printout is not so good. So hell, yeah. Yeah, you can type properly, but I'm just for demonstration purpose. Okay, so why \b? Actually, what you print out is hello. If you add \b, is MATLAB will going back to remove the last digits. Okay, so if you add one more \b, is going back. Hello, remove 2 letters at the end. Okay, so this is the some extra demonstrations about some special character. So I'll quickly demonstrate another thing is, for example, if you want to print out single quote, you add a double quote here, remove \b. So you print out hello with the single quotes. So single quotes in fprintf become double quotes. Okay, same as the percentage. Okay. So this is some examples. If you're interested, you can practice in your lab. But this majority of the example I have demonstrated you. So this probably I will demonstrate you in the next lecture. So I will try to finish this fprintf within time. So what time is it? So fprintf, as I just mentioned, percentage f is fixed point printout, okay? But you can really get more printout with the specified width and precision, okay? So how do you do that? Between percentage and the specifier, you put width dot precision, okay? So for example, if you didn't specify anything, percentage f, 6 decimal places, okay? But if you say .2, that means the precision is 2. So you have you print out have 2 decimal places, okay? But if you say 20.2, that means the first 20 is spaces, is width. That means from the beginning to the end of printout, this whole thing occupied 20 space, and precision is 2. So normally you specify this width is to align the printout normally. So next printout is 20.2e, is exponential printout, also occupy 20 space. So you see they are well aligned, right aligned each other. So 20s is a printout string in 20 space, okay? So these 3 printouts you can find out they are all well aligned. This is a more specified width and precision that you can define yourself, okay? So these multiple variables I have mentioned, so you just list all the format of each variable and print out them all together. So fprintf with matrices. So in fact, with matrices similar to this multiple variable printout. So let's see this example. This example is also the last lecture's example. Is for the mining company, the debris drop. Ask you to analyze the risk, so that giving you the height of conveyor belt and calculate the debris fall to hit the ground, the speed and the time. So we made a function, debris drop function. So giving you h is input, the height, okay, where the debris drop, the height, and then ask you to calculate t and v. T is time and velocity. So here we don't really care about this computation. What we cared is the fprintf. So let's see, there's 3 lines of fprintf. So first line is just a line of text. So all values are matrix, this and that. So the second line is specified the width of the printout is 10. S means string. So that means you say you list printout. This means you list printout 3 string, height, and then time, and then velocity, and using 10 space. So you have height here, time, and velocity, and they are all occupy 10 space, okay? And then followed by the fprintf, 3 variables. So you specify the width is 10, so it's well aligned, okay, with the previous string. .2, precision is 2, okay? So you print out 3 variables. So HTV, okay, you print out each value of H, value of T, value of V, okay, because the HTV is a vector, so you grab the first value of vector you print out, and it's well aligned. It's 10 space here, 10 space here, 10 space here, and then you print out the whole H, whole T, whole V. So I'm going to show you this printout here. So this is basically this printout. So this is first fprintf. This is text. Second printout is the string, height, time, velocity. They all occupied 10 space. And follow this whole thing is H, T, and V. And you see this is also because you specify 10 width. So it's all well aligned printout. Okay? So this is telling you why we need width and precision when we print out using fprintf. So this is the this is fprintf, okay, for matrices. Now fprintf have another application. This fprintf can also write to a file. So when you have a file, what you're gonna do? Okay. So first thing is actually these few lines. Actually, the sequence is like this. First thing is to open a file using fopen. Okay. So fopen is a built-in function. Fopen followed by file name. You can input any file name, for example, text.txt or abc.txt, the file name you want, okay? This is your created file name. Followed by mode. Mode has 3 modes. WT means it can be, you create a new file, and then you write everything into that file. Or you already have a file there, and then you write something, overwrite that file. So it's WT. Or the mode is AT, is append text. You already have a file, and then you add at the end of the file something new. OR is reading from the file. So once you create, you use fopen, called create file name and mode. Okay. So this fopen will automatically create a dummy variable and assign to file ID. This file ID doesn't mean anything, but it just is something that point to this file. Okay. So then the second line that you should do is fprintf. So use the same dummy variable here. And because here is by default is to saying fprintf to the same file, okay, followed by format and the variable you want to print out, okay. And at the end, the third step is here is fclose, FID, okay. So it's closing this file. Once you use fopen, at the end, you must use fclose. It's a pair. You open a file, you close a file. This is just in case someone else taking the computer and write something into your file. So fopen, fclose, you always put this pair together, and in between you put fprintf to that file. Okay, that is the sequence, how to write to a file. So again, this is exactly the printout to the matrix example, debris job matrix. This is exactly the same example. So what we changed here is instead of directly print out, we print to a file. This file, okay, as I said, first you open it using fopen. File name here is already given, is defined at the beginning of the file, okay? And you point out the mode is writing to this file, okay? And then followed by fprintf, exactly same fprintf command. It's just because you print out to a file, you put file ID, this dummy variable here, okay? And fclose fclose this file ID. So as I said, you use fopen, you use fclose at the end. You always make them as a pair. So this is basically the printout as I showed, okay? So, and this printout is printout to a file, debris.txt, okay? So, okay. This is the fprintout to a file. Now, the last topic I want to talk about is another built-in function, fgetL. Okay, fgetL is to get a line from the file. Okay, so followed also by file ID. Let's see an example. to understand. So F-get-L, there's a one point is every time you use F-get-L, it can only read one single line per time. Okay, so if you read, you have multiple line, you're gonna use later on. We will use a loop. Okay, every time you read a line, every time you read a line. So this is F-get-L. Now we see an example. So this example is to saying, giving you a temperature.txt. So you have a 15 degree, 20, 8, 9, 11, 12, 5. Okay, this is in the text file, temperature.txt. Now, we call this file name is temperature.txt. Open it. The mode is read. Okay, reading it. Then we use F-get-L. Okay, to get it. F-get-L followed by this dummy variable. Okay, so and then you assign that line to temperature, and then you fprintf directly. You call built-in function to compute the average. Mean is a built-in function. Means you compute average. Okay, so for example, so this automatically give you an average. So, but then this is a printout. This is average. Average temperature is 44.3. Is it correct? So if you go back to the temperature given you, it looks like nothing above 20 degrees. And why you get average temperature 44? So there's something wrong. Okay. So I can tell you why it's wrong, because F-get-L is a built-in function that I said every time it gets a line. Okay. So you read it will read a single line, but it will read this single line and treat as a string. Okay, and then give back to temperature. So what temperature averaged is a string. Okay, so how do you correct this line? Because you want to get a number, string to number. You add a string to number here. Okay, you add a string to number and then it will work. So F-get-L is very special. So two things remember of F-get-L. One is every time read one single line, okay? And that line is a string. So if you want to calculate the number string to number. So I'll try to demonstrate this example and another example in the next lecture. Okay, here. So using my laptop. So I'm ending the lecture now. I will see you on Friday.